Listen, I get it. You're feeling cooked in AP chemistry already, and the year hasn't even really started. Welcome to just a survival tips and tricks for the first unit of AP chemistry. My name is Corinne, and I have all these social media accounts to try to teach and help as many students as possible. I was a high school teacher, I taught AP chemistry, and now I've worked with really cool companies like Khan Academy and Chegg and Marco Learning, just like I said, just trying to write content and teach as many students as I can. But enough about me, let's get into the chemistry. So this is what we're going to talk about in this video. I'm going to try to go through it as quickly as possible, just give you a brief exam and course overview, some tips and tricks, and then just review the essential skills that you'll need when you walk in the door on day one. So here are the exam details. Your exam is going to be split into a multiple choice section and then a free response section. You'll have 4 short answer questions and 3 long answer questions. And your exam is going to be a hybrid exam. So what that means is that your MCQ section will be on the computer. For your FRQs, you'll see the questions on the computer, but then you'll have a booklet where you will actually get to write your answers. There was a lot of drama last year with the periodic table and the equation sheet. The hope is that you will also have access to those on paper, so you're not constantly flipping through windows, but more to come on that. So this is the breakdown of the course. This is just College Board CED. These are the topics that you will cover this year. Notice that there are certain units that are weighted more heavily. Unit 3 has the highest weight because it just covers so much. Not only does it cover intermolecular forces, you're looking at gases, gas laws, properties of solids, all kinds of things in this unit. That's why it is such a big unit. And then unfortunately, Unit 8, that is another big unit because it is a lot of new material, often the most difficult content, but you don't need to stress about that yet. You will be at a point where you are more prepared for that when it hits in March or April. So what do the FRQs look like? This is just an FRQ from 2021 to give you an idea. It's actually a photoelectron spectroscopy one if you are working through Unit 1. This is topic 1.6. So this kind of gives you an idea of what an FRQ looks like. You're going to hit all kinds of different aspects of chemistry. This is a cumulative exam, so you expect to see lots of different questions as you work through parts A through F. Also with this, know that error carries forward is something that the readers will follow when they're grading your exam. So don't stress. If you don't know how to answer part A, but you can figure out parts B and C, you'll still get credit for that. So let's look at the results from last year's test. We don't know exactly how many students took the test yet, but we do know that 78% of them scored between a 3 and a 5. So the odds are pretty good, right? So even if you are feeling completely overwhelmed right now, chances are on May 5th, you're going to be really prepared for this exam, and the class is going to feel like the hard part. And let's say you've decided not to take the exam. I'm all for that too. So taking AP Chemistry, whether you take the test or not, is going to be a really valuable experience. A long time ago when I was in AP Chemistry, I actually opted not to take the exam because I knew I wanted to major in chemistry. I'm so thankful I took the class because guess what? Gen Chem was a breeze. So there are benefits to enduring this rigorous class. Maybe this is the first time you've really struggled. I promise you're going to walk out of this a stronger student. So let's get into the tips and tricks. These are all going to be just very basic tricks, but guess what? The little things make a big difference in this tricky course. So the first thing I want you doing each day is taking your own notes in class. Just taking a screenshot of your BFF's notes, that's not going to suffice. You need to actually put the pen to paper and work in some of that muscle memory. After you take your notes, I don't want you to shove them in the bottom of your bag and let them sit there until April either. I want you revisiting those notes, whether you're highlighting things, reading through it, rewriting them. I want you actually looking through them so you have an idea of what you actually know. It's one thing to listen to your teacher lecture and think, oh yeah, this makes sense. It's another thing to look at it 6, 7 hours later and realize, oh wait, yeah, I have no idea what's going on. My next tip is just to stay organized. So as I've mentioned, this is a cumulative course. So everything that you're learning now, you're going to build upon that. So you need to know where your notes, your labs, your assessments are, so you can refer back to them. My next tip is just to familiarize yourself with the tools you're going to have access to on all of your assessments and on exam day. So that means actually bringing your calculator to class so you know exactly where to find the log function and the exponents. I also want you printing out a copy of College Board's periodic table along with the equation sheet, because guess what? If you aren't familiar with exactly where to find Faraday's constant on this equation sheet, you don't want to be wasting time looking for that. You want to know exactly where everything is. It's organized pretty well. But you also want to recognize the College Board's periodic table does not include the names of the elements. So yes, you need to know that tungsten has a symbol of W. You need to memorize those. If you need help with that, I do have a set of flashcards that will help you with that. All right, next tip. I want you to complete every single problem set that you are given, even if it's ungraded. The best way to do well in this course is to complete active practice. There are so many different ways to ask these questions. I'm sure you've seen that with stoichiometry. The more you are exposed to these different types of problems, the better prepared you're going to be. Right. Other thing I need you doing is you need to ask questions. If you have questions, chances are 4 or 5 people around you have those exact same questions. Do everyone a favor and ask them. Otherwise, your teacher is just going to continue yapping, assuming that you guys know what's up. You have no idea what's going on, so let your teacher know. If you are in a spot where you don't feel confident or comfortable asking your teacher questions, ask me. I do this for fun. That's why I have all these accounts, and I want to help you out. So ask questions. The other way you can ask questions, a low stakes way to ask questions, right, is to form a study group. Find the people in your class who have the same goals as you. Work together, cry together. It is all helpful. And then the other thing I want you doing is using the outside resources that are available and are free. There are so many people out there who want to help you, so many courses, things like that, that are entirely free just to provide extra practice and support through this rigorous course. And here's some of my favorites. So Khan Academy, if you are not aware, they have a Chem 1 course, really helpful at this time of year just to review some of the basics. They also have an AP course already built out. All of the videos are pretty short. There are exercises, articles that explain things. Check it out. If you are more into YouTube, Jeremy Krug is the GOAT right now in AP Chemistry. He has so many videos out and is constantly publishing more. And then Michael Fairbaugh was actually my mentor teacher back in the day when I decided to switch careers and become a teacher. He has so many great videos where he just goes through practice problems and he writes these problems. They're all really well, they all align well with what you're going to see on the exam. Definitely check out these 2 YouTube channels. And then if you're more into interactive things, that's how I am. I'm not crazy about long videos. I'm going to try to keep this one short. Check out my flashcards, problem sets, and short form videos. My goal is to create more YouTube videos this year, maybe just unit overviews, things like that, where I also include free problem sets for you. So you can work through those problem sets, you can check out the keys, and make sure you have all of the practice you need under your belt before you sit down to take the test. So here are all of these tips. Go ahead and screenshot this if you would like these tips. Again, they're all really simple, but guess what? The little things make such a difference. Be consistent with this, and then when it comes to May 5th, you won't be scrambling to make sure you're doing well on this exam. You're already going to be set up for success. All right, so walking into AP Chemistry, you've probably realized that on day 1, you're expected to know everything from Honors Chem, right? Like you're just expected to know it, even if you took Honors Chem as a baby sophomore 2 years ago. It's okay. These are the essential skills that you really need, and you're going to build on all of this. So let's work through each of these. So bonding and nomenclature. You really need to feel confident writing the names and chemical formulas. I do recommend memorizing the polyatomic ions. Technically, you don't have to, but it's just going to make your life easier. I hate memorizing things. That's why I didn't major in biology, right? I love that you can explain most things in chemistry. Memorize the polyatomic ion, so I promise it's going to make your life 1,000 times easier. So let's try it out. Pause the video here, see if you can name these compounds. All right, so that first thing you need to do is decide, are these ionic or covalent? So right away, I know that the first and third ones, those are going to be ionic. Third one's easier to identify because it includes a metal, ionic. 2 or more nonmetals, typically covalent. That first one is the exception. So ammonium is our positively charged polyatomic ion. It is going to transfer electrons to sulfate. So because there's a transfer of electrons, that's also ionic. So we're only going to use prefixes with covalent compounds. So these are the names. So that first one, ammonium sulfate. Second one, tetraphosphorus, because we have 4 atoms of phosphorus, 10 atoms of oxygen. And then that last one, had to throw a transition metal ion in there. That's going to be vanadium 5 chloride. So what you have to do is use the charge of the anion, the negative portion or second portion of that formula, and work backwards. Each chloride ion has a charge of -1. We have 5 of those. That means the positive cation has to be equal and opposite to that. So that means the positive vanadium has to have a charge of 5. All right, moving on. Let's talk VSEPR, polarity, and IMF. So if you have a pretty good grasp of these, it's going to be really helpful in that second and third unit. So let's look at this. Pause the video here, try this one out. Which intermolecular forces will the compound on the left experience? And I should say there are multiple, so I should have had better phrasing for this. But look at this, and right away you're going to know it's going to experience London dispersion forces because everything experiences London dispersion forces. Then we need to decide, okay, does it include any polar bonds? So looking at this, we have a carbon to carbon bond, we have carbon to hydrogen bonds, and then we have that carbon to oxygen bond. The carbon to carbon bond is going to be nonpolar, right? These electrons are going to share, carbon's going to share equally, right? So you have the carbon has the same electronegativity. Carbon to hydrogen bond. I wish I could have a tattoo of this. The CH bond is nonpolar. Remember that. So they're going to share electrons equally. Therefore, that hydrogen is not in a polar bond, and we're not going to experience hydrogen bonding. The carbon to oxygen bond, however, is going to be polar. So what that means is oxygen has a more significant electronegativity compared to carbon. Therefore, the electron density is going to be shifted slightly towards oxygen, creating a partial negative charge on that oxygen atom. Because of that, this will experience dipole-dipole interactions. This compound is actually acetone. It's the compound in nail polish remover. So if I have multiple, obviously when I have molecules of acetone, we are going to experience dipole-dipole interactions and London dispersion forces. If the acetone were dissolved in water, then we would also experience hydrogen bonding. But again, for hydrogen bonding to occur, we have to have hydrogen with that partial positive charge. So hydrogen has to be in a polar bond. We didn't talk about ion-dipole interaction, so let's talk about that briefly. So an ion-dipole interaction occurs when you take an ionic substance and you dissolve it in a polar solvent. So as you can see here, we had sodium chloride, separates out into Na+, Cl-. Then each of those ions is going to interact with the oppositely charged part of the water molecules that it has been dissolved in. We don't normally see this on the AP exam, but guess what? We saw it in 2025. So of course, hopefully your teacher's going to spend just a little bit more time on this. This is actually the strongest interaction. We also have dipole-dipole interactions between two polar molecules. Hydrogen bonding is a specific type of dipole-dipole interaction. Again, you have to have a polar hydrogen, and that's going to interact with a very electronegative atom, whether that's fluorine, oxygen, or nitrogen. And then finally, we have the London dispersion forces. Again, everything experiences this because it's due to the random movement of electrons. Promise you're going to spend a lot more time on this year. When it comes to periodic trends, I don't want you just talking about the location of elements or the arrows. That's a big, don't do that. All right. What you want to do is describe what's actually happening. So everything comes back to the atomic radius. Get really solid with that trend, and then you'll be able to describe ionization energy, everything else. And if you're stressing right now about electron affinity, know that that trend is not as trendy, right? It doesn't actually follow a specific trend. Generally, it's going to increase across periods, but there's a lot that changes with that. So it's not as predictable. And because of that, on the AP exam, we saw a multiple choice question over 10 years ago on this, but you want to focus on the sign of the electron affinity. If you have a negative electron affinity, that's actually going to be a favorable electron affinity versus a positive, that would be an unfavorable endothermic reaction. All right, let's actually practice with this. So this is the type of multiple choice question that you might see in Unit 1. I want you to predict the likely identity of the third period element indicated with a question mark. So check this out. Think about that. Okay, and what you should notice is this massive jump between ionization energy 3 and 4. What does that mean? That means we've switched from the valence or outer shell electrons into the inner or core electrons. Those are going to be a lot closer to the nucleus. They're going to experience stronger coulombic attraction. Therefore, they're going to be harder to remove, and it's going to involve a much higher ionization energy. That's how you're going to predict the identity of this as aluminum. You could use the same process here, looking at i.e. 2 versus 3 for that second row to identify that as magnesium. Noticing there's a huge jump after that second, indicating that this element has 2 valence electrons. All right, and last but not least, stoichiometry. This is the one that has been in my DMs the most these last couple of weeks because this is the hardest topic from Chem 1. And then guess what? Day 1 of AP Chem, you're just supposed to run with it. So let's just talk about the basics first. Get really solid with understanding mole conversions. I've linked some videos in the notes. Check those out. I also have a stoichiometry strategy just to help you decipher. The goal of stoichiometry, right, is to compare two substances in terms of their mole ratios. Only way to do that is to convert whatever you're starting with into moles. So that's always step one. Convert either your mass, your volume, into moles. Then you can use the coefficients from the balanced equation to change from moles of your known quantity into the moles of the wanted or unknown quantity. From there, you'll then decide what you want to convert that into. Or maybe you just have to keep it as moles. That's a lucky time, right? It happens. So sometimes you have to recognize in AP Chemistry, there are going to be some questions that are kind of easy. So don't overthink it too. So let's look at an example. This is just a fun example. Definitely do this reaction in a video at some point. This is the reaction to make fake blood, commonly used in movies and even theater productions, things like that. You take two clear solutions, mix them, and boom, bright red solution. All right, so if we have 5 grams of each of these reactants, how much of that fake blood, that iron 3 cyanide, will we produce? So what you want to do first is you want to balance the equation. And I purposely gave you the equation because sometimes you are going to be given the equation. Sometimes you're even given normally you're even given the molar masses, but I didn't do that. I wasn't that nice with this one. So first thing we want to do is balance this. When balancing an equation with polyatomic ions, that thiocyanate, the SCN, count the thiocyanates as a single unit. Notice that you'll see 3 of those on the product side. Let's throw a 3 in front of the potassium thiocyanate. Then we need a 3 in front of KCl, and now this is balanced. Your next step is to organize what you know versus what you're looking for. I like to put all of my numbers directly underneath the equation. I think it's just the easiest way to keep track of things. So we have 5 grams of each of those reactants, and we are looking for grams of that second product. Now we got to determine which is our limiting reactant, because even though we're starting with equal amounts of each reactant, one of them is going to produce less iron 3 thiocyanate, and that is what our actual yield is going to be. So first thing we always have to do is convert from grams into moles. So that's what I've done here. I've divided by the molar mass of each reactant to change that into moles of each of those reactants. Now I can use my mole ratios. So for example, the potassium thiocyanate KSCN, it is a 3-to-1 ratio. So I'm going to multiply by 1/3 to figure out my moles of iron 3 thiocyanate that I'm going to produce. The iron 3 chloride has a 1-to-1 ratio, so those would be equal moles. So you notice that the first reactant produces less product. Therefore, that is what is going to limit our reaction, and we don't need to worry about the iron 3 chloride any further. Now our last step, we're going to calculate the actual yield by multiplying by the molar mass of our product, right? So anytime you're converting from moles into anything else, you're going to multiply. I know, so corny, but it's going to help you remember how to approach this. So now I have my yield. That is way too many decimal places though, so we're going to have to round for sig figs. The easiest way to do this is to look at your initial The only way to do this is to look at your initial values. I have 3 sig figs with each of those, 5.00. Yes, so zeros matter. Therefore, my final answer should also have 3 sig figs. Thankfully, there's only 1 point on the AP exam that is associated with sig figs. So typically, if you round things to 3 sig figs, you're going to be safe. I can't promise that your teacher feels the same way. So get in the habit now of looking at those initial values and then rounding your final answer to match the precision of your least precise value. A big request in my DMs this week has been empirical and molecular formulas and combustion analysis. This is the rhyme I teach: percent to mass, mass to mole, divide by small, multiply to a whole. If you use that process, you can figure out any of these questions. When it comes to finding the molecular formula, you find the molar mass of your empirical, compare that to the given molar mass, see how many times you need to multiply up that empirical formula. When it comes to combustion analysis, it is one additional step where you're taking the mass of CO2 and the mass of H2O, converting that into moles, and then changing that from moles of CO2 into moles of carbon. It's not that difficult, but it takes some practice. I've linked an old tutorial here, and my goal is to also publish a new one next week. Then the other request has been electron configuration. You just have to practice with this. Get a periodic table. It's time to do some coloring. Map out where you find each of those orbital types. So first 2 columns, you have your S in. And if you're unsure of your answer, just add up all of your exponents. If you add up all the exponents, you should have the atomic number, which if you're looking at a neutral atom, that should match up. All right, if you're looking for more practice with some of these basic topics, please check out my Chem Bootcamp course. If you use the code LIVE through this weekend, you will get 50% off that course. So it's not even $5. Just 5 modules with short lectures, practice, and assessments just to help you feel more prepared for AP Chemistry. So thanks for watching. Please help me help more students by sharing my account. And as always, if you have questions, drop them in the comment section. I will be responding to these. I'm the only person running this account. So if you get a response, it is from me because I want to help you out. You've got this.